Welcome so much to our learning today. And today we are going to have a very interesting lesson that is on grade 9 concept on indices and logarithms. So in our previous video, we had done an introduction, that is to the indices, how we are able to represent a number in index form. So today we are going to go further and check on specifically on the laws of indices, and also we're also going to check on the logarithm part of it. So this is a grade 9 concept. So you are a learner, you are preparing for your KCSE this year. You are welcome to this class to learn and enrich yourself as you prepare for your national assessment. So we are going to begin on the laws of indices. We are going to begin on the laws of indices. So the laws of indices, these are laws that are going to guide us as we are going to do our calculations on the laws of indices. That is any of our arithmetic problem that is involving indices, we are going to use our law. So the first law is the multiplication law. The first law, it is our multiplication law. So we have our multiplication law. So in this multiplication law, there are a few things which we are going to consider. And on the multiplication law, it states that when you have a number a raised to m multiplied by a number a raised to n, the answer to this is going to be a into m plus n. So it means this: when you have the multiplication sign connecting two numbers that are written in index form, and it's not just index form in which they are written in a way that the bases are the same. In our previous class, we say that when a number is expressed in this form, this one becomes our base, and then this one becomes our index. So the number which is being raised, that is the number that is raised to a number of times, becomes our base, and the number of times to which a number is going to be raised is going to be our index. Again, we can also refer it to as our power. So on the multiplication law, you're going to realize that in the case whereby there is a connection by a multiplication sign of that is the numbers that are expressed in indices, but again of the same base, then we are going to do this. The only thing we are going to do is add our powers, and that is why we have a into m plus n. So in this case, our numbers a, b, we have a, m, and n. They can be integers. And an integer, it can be a positive integer. That is a positive. It can be what? It can be also a negative integer. And again, 0 is also an integer. So what does it mean? So on the multiplication law, the sign that is connecting the two indices is what? Multiplication. So for that case, we are going to introduce, that is the addition on the powers. We are going to have an example. We're going to have an example of the same. So in this case, we have number 1, evaluate 2 raised to power 3 times 2 raised to power 4. Evaluate 2 raised to power 3, 2 raised to power 3 times 2 raised to power 4. So from this case, we are realizing that our numbers 2 and 2, they are the same, which are our bases. So what do we do? If this is 2 power 3 and this is 2 power, that is a 4. So we are going to have a solution of this nature. We have a number 2 raised to power 3 times 2 raised to power 4 is going to give us a solution of that is A. So we are going to have 2 here. And then we are going to have M for our case is 3 and N for our case is 4. So it's going to be 3 plus 4. So it's going to be 2 power 7. So when told in index form, you just leave it in that nature. You just leave it in that nature. So in our case, that is how we go about multiplication law. So we can check on the second one. You can check on the second one, that is the division law. Our division law. So for the division law, it states that when you have a number expressed in index form and they are going to be b raised to d divided by b raised to c. b raised to d divide b raised to c. So all these letters, they are going to be just integers. And for our case, they must be having the same base. If the bases are different, then they cannot, be done using the laws of indices. But you're going to use a different method. So in this case, you are going to realize that b power d and divide b power c. It's the same as b power d divide b power c. And the solution is going to be b into, that is b raised to d minus c. b raised to d minus c. So what happens is this. When we introduce the division sign between indices, then when we are solving them, we are going to subtract the powers. We are going to subtract the power. That is why we have b and c. In the place of division, we have done what we call subtraction of the powers. So we can have an example. So our first example is solve. That is 3 raised to power 4 divided by 3 raised to power 1. It's going to give us. So our solution here is going to be this. Because according to this law, we are going to do subtraction on the powers and our base is going to remain the same. So our base is going to be 3. But what do we do to the powers? We subtract them. And it's going to give us 3 raised to power 3. In index form, you can leave it that way, but when told to solve it, ensure you multiply 3, that is 3 times, which is around 27. So the next law, which we want to look at, is we have the power of powers. There are so many ways it can be, defined, power of powers. So these are principles or guidelines in solving most of our solutions, that is problems involving indices and even part of the logarithm. So in this case, we have an index number, let's say a raised to b, and again it is raised to c. So a raised to b into bracket again raised to c. So that is why we have the power of power. So a number is already raised to a certain power, but again we raise it to a certain power. So our solution here is going to be a into b times c, which is the same as a, b, c. So for that case, we do multiplication. And in this case, we can have just one example. We have number 1, evaluate, that is 2 raised to power 3 raised to power 2. Evaluate 2 raised to power 3 raised to power 2. So our solution for this case is going to be 2 raised to power 3 power 2 is going to be 2 raised to power 3 times 2. And it's going to be 2 raised to 3 times 2 is power 6. So in index form, it's going to remain at that position. In index form, it's going to remain at that position. Now, in the powers of powers, a number can be raised into a fraction. We have this. A number can be raised into a fraction. So we have a law that is guiding our fractional indices. We have the fractional indices. So on the fractional indices, it means that a number has been raised to a certain fraction. For example, we have a raised to m over n. So the solution to this is going to be the root of a, that is the ninth root of a powered by m. We are going to do an example and then we are going to understand it. Now, a number a raised to into a fraction which is m over n. So the solution is the ninth root of a and then multiplied or raised to power m. And in that case, the letters are representing different numbers. Remember, we can find a square root, a cube root, a fourth root, that is, and many others, depending on what you are given in your question. So in this case, we can have an example that is going to guide us in that case. So evaluate, we have 4 raised to 3 over 2. 4 raised to 3 over 2. So for that case, it is the same as, if we equate this to this, our number, a raised to m over n is equals to 4 raised to 3 over 2. So for our case, a is equals to what? A is 4, n is going to be 2, and then m is going to be 3. Now, the solution to this, a raised to m over n, is going to be that is the ninth root of that one, then a into power m. So in that case, we are going to have the same apply to this 4. So 4 raised to 3 out of 2, 4 raised to 3 out of 2 is going to be the square root of what? Of 4 and then powered by, that is multiplied by power, that is 3. So m has taken that is a 3, a is 4, and n is what? 2. So the square root, 2 means a square root. If you have it as 3, then it's going to be the cube root. If you have it at 4, it's going to be the fourth root, fifth root, sixth root, and others, for depending on what you are given. So in that case, we are going to have the root of that is 2 raised to power 3. So 2 raised to power 3, the answer is 8. 2 raised to power 3, the answer becomes 8. So in that case, it means this, that our, that is, solution on fractional indices can be guided by that principle. It can be guided by that principle. So as you meditate upon it, there is other guidelines that are going to guide us on evaluating or doing questions to do with indices. Now, a number can be raised to 0. A number like 1 can be raised to 0. A number like 10 can be raised to 0. So, in that case, another thing we need to understand is this. Any number, that is part E, any number raised to power of 0, the result is 1. Any number that is going to be raised to 0, and the number should be a non-zero digit. So any non-zero digit raised to 0 is going to give us a result of 1. That means that a raised to 0, the answer is 1, where a is any non-zero integer, where n, that is a is a non-zero integer. So any number raised to 1 is going to give you, any number raised to 0 is going to give you 1. That is on the indices. So 1,000 raised to 0, the answer is always 1. 1,000,000 raised to 0, the answer is always 1. Now, all of these, they are going to still guide you on how you are able to solve, that is, our questions on indices. Maybe the last part of it we have the part of f, we have a number raised to n, negative n, is going to give you the same as the reciprocal of the number, that is a number raised to negative n is the same as 1 over a power n. So what we need to understand is this. There is the change of the signs. There is the change of these powers here. And that means that our number a raised to power negative n is the same as 1 divided, that is a power n. So the power here is going to change. And that means that a raised to n is the same as 1 over a raised to negative n. So the powers are going to change, and when you are finding the reciprocal of those numbers. So those are the key things that are going to guide us in, that is, our solving questions on indices. Now, we will need to look at a few examples on where we are able to apply our indices and the logarithms, where we are able to apply our indices and the logarithms. So in that case, we can have our first question. We are going to do a good number of them so that you are able to understand clearly on how these questions can be done. You are able to get it right on how you can solve such like question when it comes to an exam. So the first question is, we have our first question. Work out the following, leaving your answer in index form. So work out the following, leaving your answer in index form. Now, with mathematics, there is what you call accuracy. And the accuracy, it comes whereby you are about to give now the final answer. And the statement, there is a key statement in the question. Like now, we have leaving your answer in index form. So inamaanisha ya kwamba you have no another option. If you leave it in maybe another different form, like a fraction or whichever the case, you are going to lose a mark on the final part. So it is good that you answer according to what has been given. So we have part A, which we have as 8 power 3 times 8 times 8 power 0. That is our first question. 8 power 3, we have 8 power 3, and then times 8, and then times 8 power 0. So in this case, you need to understand this. 8 is the same as 8 power 1. So there is a power 1 there, which means that we only have 8 as a single. So in that case, how do we go about it? So the solution is, we have multiplication on both sides. That is the multiplication sign connecting the three terms. There is the 8 power 3, 8 and 8 power 0. So what happens here is this. We are going to introduce a division, not a division, but addition on the powers, and then we are going to maintain our base. So we are going to solve it as 8 into 3 plus 1 plus 0, which is going to give us 8 power 4, which is going to give us 8 power 4. So 8 power 3, 8 power 1, 8 power 0. So what have we done? According to the law of multiplication, we are now going to maintain the base, but on the powers, we are going to add them. So we are going to add 3 plus 1 plus 0, which is going to give us 8 power 4, which is going to give us 8 power 4. We have the second one, 2 power 0 times 2 power 5 times 2 power 3. So I'll give you a minute so that you are able to go through it. Check on whether you have understood. I'll give you just about a minute, less than a minute. You try it first before I do it. Now, I believe you have been able to solve it, so let's confirm what your answers are. So our solution is going to be, now we have multiplication again, so we are going to maintain our base, and then we add the powers. So 2 power 0 times 2 power 5 times 2 power 3 is going to give us, so we maintain the power, which is 2, and then we have 0 plus 5 plus 3, which is going to give us 2 power 8. It's going to give us 2 power 8. Our question must be left in the form of index form. So we have the third question here, which we want to attempt again. 3 power 2 times 3 power 5 divide 3 power 2. So for that case, we are now having two signs. So that is, there is a multiplication and then division. So it means that we are going to combine both the division law and division, that is a division law and multiplication law. So wherever there is a plus, wherever there is not a plus but a multiplication, on the powers we are going to have addition. Wherever there is a division, on the powers we are going to have a minus. So our solution becomes 3 power 2 times 3 power 5 times, not times, we have divide 3 power 2. It's going to give us, we maintain the base. So 2 plus 5, going to be 2 plus 5. Now on the division, we introduce minus, and then 2. And then our answer is going to be 3 power 5. Our answer is 3 power 5. We have another question we need to attempt here. We have that is part D. We have 11 raised to 0.5 and then power 4. 0.5 power 4 divided by 11. 11 raised to 0.5 times power 4, then divided by 11. So what happens here is this. Number one, we are going to check on what we are given. A division sign has been given, so we are going to use the division law. But again, there is a law on the powers of the powers, which is going to be used here. So we have to solve this. So 11 raised to 0.5 times 4 is going to give us 11 raised to what? Raised to 0.5 times 4 is 2. So it's going to be 11 power 2. So we introduce this one, 11 power 2 divided by 11 power 1. We said 11 that is single is the same as 11 power 1. So it's going to give us 11 because we maintain the base, and then we have 2 minus 1, which is 11 power 1. Remember, our question was we must leave our, that is the answers in index form. So it should be 11 power 1. It should be 11 power 1. So we have another question still. 9 power 2 power 3 times 9. 9 power 2 power 3 times 9. So in that case we have 9 power 2 power 3 is the same as 9 power 2 times 3, which is the same as 9 power 6. So we have solved the first part. So we join the second one. It's going to give us 9 power 6 times 9 power 1. It's going to give us 9 into 6 plus 1, which is going to give us 9 power 7. It's going to give us 9 power 7. So in that case, we have solved it. We have another one which we really need to try again. We need to try it because if we don't get it right when it comes to the national assessment, you may have it very tough. But that is why we are here for you, so that at least at the end of the day, you have a mark to earn in your KJSEA. And have the right attitude. In mathematics, we always have the positive attitude. So we have b power 4 times b power 6 divide, there's a bracket again, b power 2 times b power 3, closed. So here there is a numbers that are in brackets, and again, they are connected by a division sign. They are connected with a division sign. So what we're going to do is this. We are going to simplify the brackets first, and then we are going to find our connection, that is by the division sign. So what we're going to do here is this. b power 4, so we are going to have b into 4 plus 6 divide b into 2 plus 3. So we have used our multiplication law to solve this one. So it's going to give us, that is b power 10 divide, we are now remove the bracket, b power 5. 2 plus 3 is 5, 4 plus 6 is 10. So we are going to have b raised to power 10. Yes, let me just continue. So we have b raised to 10 divide b raised to 5. They have the same base, so we introduce minus on the powers, which is going to give us b raised to 10 minus 5, which is going to be b raised to 5. So that is our solution to this equation there. That is our solution to that equation. So we have another set of questions you need to check. I say today we are going to do a number of examples because mathematics needs a lot of practice, and the more you practice, the more you understand. The more you do it, the more it sticks in your, that is, brains and the head. So we have the following questions. So we have number 2. Find the value of x in the following. Find the value of x in the following. So the following, you have a number of them. So the first one is 3 into x plus 1. 3 raised to power x plus 1 is equals to 81. So here we are just supposed to find our, that is the value of x. And one thing is very important here. In the previous questions we have done, there was no equal sign, but now we are introducing it. And again, there is a guiding principle on us solving it. So for us to equate the powers, then the bases must be the same. So what do we do here? Number one, the base here is 3. Our question is, can 81 written to base 3? It can be written. 81 can be written to base 3. So 81 written to base 3 is the same as, that is 3 raised to power 4. So our solution is this. We have 3 raised to x plus 1 is equals to, now 81 is the same as 3 raised to power 4. And I repeat again, you can only equate the powers when the bases are the same. If they are not the same, make them have a similar base. So from here, we can now equate the powers. It's going to be x plus 1 is equals to 4. X is equals to 4 minus 1. This one comes this side, it becomes a negative. So x is equal to 3. The value of x is equal to 3. Now, let's prove this. We have to prove it. Now, if the value of x is 3, we replace it in our equation. So, we have to prove our equation. So, it's going to be 3 into x is x plus 1 is equals to 3 power 4. So, 3 into 3 plus 1 is equals to 3 power 4. 3 plus 1 is 4. So, 3 power 4 is equals to 3 power 4. So, our question is okay. The value you get here for the any unknown that you will be given in your assessment, you should be able to prove it. Mathematics, there is no any other way you can do it without proving. The answer you get, if you replace it in the gap, it makes the question to be complete. It makes the question to be complete. So we have B here. We have 7 raised to power x is equal to 1 out of 49. Now, this is a very nice question here. This is a very nice question. We have 7 raised to power x, and then is equals to 1 over 49. So, the most important thing is this. Express every number to a certain uniform base. And the base here that is guiding us is base of 7. So, we can write, that is 7 raised to x is equals to 49 is the same as 7 raised to power 2. 49 is the same as 7 times 7. 7 times 7 is the same as 7 power 1 times 7 power 1. So it's going to give us 7 power 2 if you add the powers. So we are going to have 1 out of, that is 7 raised to 2. So, but this 7 power 2, it can be rewritten in a different case. It can be rewritten in a different case. And that different case, we say that there is a principle that we are given where a raised to negative n is the same as 1 over a raised to power n. So our 7 power 2 is the same as a power n. But now we have 7 power 2 here. So this one can be equated. We find out the reciprocal. So this one can be written as 7 power negative 2. This 1 over 7 power 2 can be written as 7 power negative 2. So we come back here. We replace this 1 over 7 power 2 with 7 negative 2. So 7 power x is equals to 7 power negative 2. Again, they have the same powers. So if they have the same powers, we can equate them. Our x is equals to negative 2. Our value of x is going to be negative 2. Our value of x is going to be negative 2. Our value of x is going to be negative 2. So on the other end, we have another question again. And our question reads, 2 raised to power x minus 2, minus 4, sorry. But see, 2 raised to x minus 4, into bracket, divide 2 raised to power 1 is going to give us 32. 2 power x minus 4 is going to give us, divide, that is a 2 power 1 is going to give us 32. So express everything here. That is the first step. Express everything in the base of 2. So our solution is going to be, our solution becomes 2 raised to power x minus 4 divide 2 raised to 1 is equals to 2 raised to 5. So 2 multiplied by 5 times. 2 by 2, that is 5 times, is going to give us 32. Now we can equate and also obey the division law. So we are going to have the same base, we can equate the whole equation. So it's going to give us x minus 4, x minus 4 minus 1 is equal to 5. So introducing the equal sign, we now equate everything that is on the powers. But if it does not have, that is the equal sign, we do not equate the powers. So it's going to give us x minus 4 minus 1 is equals to 5. X minus 5 is equals to 5. So here we are going to have x is equal to 5. This one comes here, it's going to be positive. So plus 5. So x is equals to 10. Our value of x is going to be 10. Our value of x is going to be 10. So in that case, we are done with that, our wonderful question. We have still a number of questions because this mathematics is even getting interesting as we continue. So 3 power 2 given to power 3, and then we have 3 power 4 is going to give us 9 power x. Now, look at this. This one is an interesting question again, because we have division, we have equal to, and also we have 9 power x. So the powers are different. So the first thing probably we can do, make the powers to be the same. So we have our solution is going to be, we have, as we do the powers, we are going to solve it. So this is power of powers, so it's going to be 3 into 2 times 6. That is a 2 times 3, which is 6. So for the upper one, it's going to be 3 power 6 divided 3 power 4 is equal to 9 can be written in terms of base 3. So 3 power 2 is the same as 9. So we are going to write 3 power 2x. 3 power 2x. So we can solve on this left side. So the left side we can use the division, whereby 3 power 6 might divide 3 power 4 is going to give us 3 power 6 minus 4, which is going to give us 3 power 2. So this whole thing here on the left side is going to give us 3 power 2. So if it's going to give us 3 power 2, then it's going to be 3 power 2 is equals to, that is 3 power 2 x. So on this end here, we have same bases but raised to different powers. So if we have the equality sign, then the powers can be equated. So it's going to be 2 is equals to 2x. So what is the value of x? Divide 2, divide 2. Our x is equal to 1. Our x is going to be 1. The value of x is going to be 1. So the value of x is going to be 1. We have another question that is now even more interesting. You have a very wonderful question here, and I pray that you'll be keen on this one. So the question states, solve for x and y. So we have a question number 3. Solve for x and y in the following simultaneous equations. So the simultaneous equation is here. 2 raised to x plus 2y is equals to 128. And then 9 raised to x divided 3 raised to y is equals to 81. So in this case, there is a concept that is integrated, that is from grade 8, the concept of simultaneous equation, and we have around 4 methods which we can solve it. That is number 1, we have elimination, we have substitution, we have matrices, and we also have the graphical method. We have the graphical method, but for the case of kids here, we concentrate on the 3, we leave out matrices. That is on the solving of simultaneous equation. So on the first case, we have this is equation 1, this is equation 2. So in that case, we have to check what is given here. This is 2 raised to power x plus 2y is equals to 128. So we need to express this number 2 here. That is, express this 128 to a base of 2. 128 to a base of 2. The next here, we are going to express all these numbers to base of 3. That is the list that we are given. So we redefine our equations. We redefine our equations, and they are going to be, that is 2 into x plus 2y, that is raised to power that, is equals to 128 is the same as 2 raised to power 7. It is the same as 2 raised to power 7. And then everything here to a base of 3 is going to be 3 power 2x divide 3 power y is equals to 3 power 4. So in that case, when we have the equality sign, that is the equal sign, we can now do what we call what? We can now do what we call equating of our powers. So our redefined equations now become x plus 2y is equals to 7. It's going to be equation 1. And then on the lower part, it is 2x minus, why minus? Because here it is a division. Minus y is going to be 4. It's going to be our equation 2. Now, next thing, you decide which method are you going to use. And I want us to use what you call substitution method. So here we can use substitution method, whereby we are going to substitute. So we start with equation 1. So we are going to have one of the letters being replaced in the other equation. So starting with equation 1, we have x plus 2y is equals to 7. So this means x is going to be 7 minus 2y, which becomes our third equation. There is a reason as why I'm numbering them, so that when you are going to solve it, it's going to be easier for all of us. So we have here, now what we do, replace equation 3 with value of x in equation. So we started with equation 1, so we are going to replace it in equation 2. And the value of x we are talking about is x is equals to 7 minus 2y. So equation 2 is here. So equation 2, we have 2x minus y is equals to 4. So 2 into x is 7 minus 2y minus y is equals to 4. So 14 minus 4y minus y is equals to 4. So this is 5y. So 14 minus 5y is equals to what? Is equals to 4. So we can interchange. This one comes here, and then this one goes there. So it is 14 minus 4 is equals to 5. Why? When you interchange the numbers on their sides, the signs before them change. So we are going to have 10 is equals to 5. Y divided by 5 divided by 5. Our y is equals to 2. Our y is going to be 2. On the other end here, allow me to do it here. We are going to now replace the value of y in equation 3. Replace the value of y in equation 3. So x is equals to 7 minus 2y. X is equals to 7 minus 2 into 2. So x is equals to 7 minus 4. Our value for x is going to be 3. So that means that we have solved our equations. We have solved our equations. So you are interested in finding the value of x and y. And at the end of the day, we have y is equals to 2 and x is equal to 3. Y is equals to 2 and x is equal to 3. Now, we are still continuing. We want to look at a part called logarithms. So on the logarithms, we need to have a connections between that is indices and the logarithms. Now, we want to connect our indices and logarithms, and then we do a few examples. Now, in index form, a number a raised to b, the answer is going to be c. For example, 2 raised to 3, the answer is 8. Now, translating this into logarithms, so we are going to have the logarithm of c having a base of a is going to give us b. In simple terms, the log of c base a is going to give us b. Now, check on this. Where is a on our index form? A is the base. And here still means the base. Now, the result is c. So we are now going to do the opposite of what we are doing on indices. We are going to do, to do a reverse process of the same. So in this case, b is the number to which the number to which a number is raised. The number of times to which a number is raised. So in this case, I want you to check this. A raised to b is going to give us c. So there is a connection between this and that. So when you have learned this, then it's going to be very easy for us to do what? To solve it out. Again, the logarithms of a base a is going to give us 1 always. Logarithm of a base a is 1. What does it mean? Logarithm of 2 base 2 is going to give us 1. 2 raised to 1 is 2. So that is what that connection means. If you have a number like log of 10 base 10, the answer is always 1. Why? This 10 raised to 1 is going to give us 10. The 10 raised to 1 is going to give us 10. So in this case, we can have a few questions connecting that is a concept. We can have a few questions on logarithms. So we have question number 4. Simplify the following. And the following part A is the log 100 base 10. So the log of 100 base 10, and you should be very careful on how the logarithmic numbers are read. They are read as logarithm of c base a. Logarithm of c base a is b. Logarithm of c base a is b. And logarithm of 2 base 2 is 1. Logarithm of 10 base 10. Logarithm of 10 base 10 is going to be 1. So in this case, there is something that is missing. On our index, that is a logarithmic number. There is a number b here that is going to be missing. So we are going to give it, that is a letter x. Now we are going to have our solution to be in index form. Our number is going to be written in a certain way. So hapa there is a number to which we must multiply 10 for us to get 100. There is a number of times. So the logarithm of 100 base 10 is going to give us an answer x. And from indices, we understand that 10 raised to x is going to give us 100. So 10 raised to x is going to give us 100. Now, this is base 10, but 100 can also be written as base of 10. So 10 raised to x is equals to 100. That is written into number of that is into base 10. Itakuwa ni ngapi? 10 raised to power 2. So our x is going to be 2. I want to repeat again. Log 100 base 10 can be solved, and we are going to find the answer by equating it in a logarithmic nature. So log 100 base 10 is going to give us an answer which is x. So the answer x is the one that we are going to look at, and it means that 10 raised to power x, 10 raised to x is going to give us 100. So 10 raised to x is going to give us 100, and 100 can be written in index form, which is 10 power 2. So because there is equality sign here, we are going to equate, and our value x is going to be 2. Our value x is going to be 2. Our value of x is going to be 2. Our value of x is going to be 2. So we have the second one here. We have the second part, log 0.001 base 10. So in that case, you are going to do it the same way. Log of that is 0.001, log 0.001 is going to give us an answer which is going to be x. So it means that 10 raised to x is going to give us 0.001. And 0.001 in index form, it is going to give us 10 raised to x is equals to 10 raised to negative 3. So you equate them, x is equal to negative 3. X is equal to negative 3. So 0.001 is the same as 10 raised to power negative 3. 10 raised to power of negative 3. So we have the part C here. The logarithm of 10 power 3 times 10 power 4 base 10. Logarithm of 10 power 3 times 10 power 4 base 10 is going to be something. So we need to find the solution to it. So we are going to have our solution is going to be, so log, we need to solve these ones first. 10 power 3 times 10 power 4 is the same as 10 power 7. So we add the powers. So logarithm of 10 power 7 is into base 10 is going to give us a letter x. So it means that we are going to equate 10 power x. 10 power x is going to give us 10 power 7. So x is equals to 7. We are going to just equate them directly. We are going to equate them more direct. So we have the last part of our lesson today. We have the last part of our lesson today. Now, find the value of the unknown in each of the following. Find the value of the unknown. Problem number 5. Find the value of the unknowns in each of the following. Find the values of the unknowns in each of the following. So we have part A here. The log x base 10 is equals to 5. Log x base 10 is equals to 5. So we are going to do it more similar with what we did. So it means that 10 raised to power 5 is going to give us an x. The solution is going to be 10 raised to 5 is going to give us x. So what is 10 raised to power 5? 10 raised to power 5 is the same as x, 100,000, which is 10 is equals to x. And we are done with our question. So x is going to be 10 raised to power 5, which is 100,000. So the value of x is, that is our 100,000. We go to the second part. 9 raised to power 12 divided by 9 raised to x is equals to 9 raised to power 3. So in that question, we are going to have, they have the same base, so we are going to have our equating of the, that is our equating of our powers. So we are going to have the solution to this is going to be, I believe by now you are able to connect very fast. So this is 12 minus, because there is a division, x is equals to 3. So 12 minus x is equals to 3. So like terms together, minus x is equals to 3 minus 12. So minus x is equals to minus 9. Divide by negative 1, divide by negative 1. X is equal to 9. X is equal to 9. So we have equated them because there is an equality sign. Without the equality sign, then we could follow that is the division law only, because we have still applied the division law whereby 9 and 9 are the same. So if the bases are the same, we introduce minus or subtraction on our powers. Introduce subtraction on the powers, and then we equate them to the other side because they have our equality sign. So we have our next number. We have part C here, which is given as 13p times 13 power 4 is equals to 13 power 6. 13 power p times 13 power 4 is equals to 13 power 6. So we are going to have our solution here. They have the same base, so we are not going to struggle with it. So it means that when there is a multiplication, we introduce addition on the power. So it's going to be p plus 4 is going to be 6. P is going to be 6 minus 4. 6 minus 4 because it has gone the other side. So p is equals to 2. That is our value of p. So we have probably the second last question for today. So we have our 4 into y power 2 is going to be 4 power 6. So for this case, we are going to solve the first part, which is 4 raised to 2y is equals to 4 raised to 6. 4 and 4, they are the same base, so we can equate the powers. So 2y is equals to 6. Divide 2, divide 2. Our y is equal to 3. Our y is equal to 3. So we can go to our last question for today. Our last question for today. Last question for today. Three raised to x plus 1 times 3 raised to 2x minus 3 is equals to 81. These are very interesting again. They're very nice questions. So we need to first express, that is express our 81 to base of 3. So redefining the equation becomes 3 into x plus 1 times 3 into 2x minus 3 is equals to 3 power 4. Initially we have said 81 is the same as 3 power 4. So we have to equate everything because the bases are the same. So x plus 1 plus, goes multiplication sign, 2x minus 3 is equals to 4. So x powers x plus 2x plus 1 minus 3, x plus 2x plus 1 minus 3 is equal to 4. So 3x minus 2 is equals to 4. Why? 1 minus 3 is the same as negative 2. So 3x is equals to 4. It comes here, it's going to be plus 2. 3x is equals to 6. So you divide 3 everywhere, you divide 3. Our x is going to be 2. Our x is going to be 2. So by that, I believe you have been able to understand quite a number of things. They were lengthy, but at the end of the day, we are done with our lesson today. So if this message about mathematics, this information has helped you, remember to always turn on the notification and you shall be getting the daily updates on when the videos are coming to you. Remember also to share this to your friends, your fellow classmates whom you are learning with, and every other person who is desiring to excel in this wonderful mathematics. Thank you so much. Let's meet in our next class.